Well, hi, good morning. Thank you so much for joining me here in my shop, where I'm going to carry on with this Seeburg jukebox amplifier, which I did a fair bit of work on a couple of months ago, mostly getting familiar with it. It really is what that amounted to. Changed some of the transistors here at the front, and realized towards the end of my last time with it that it really needed 4 new output tubes. Well, those 4 output tubes are in this box. The other thing it needs is a whole bunch of 12AX7 tubes. 1, 2, has one here, 3, well, just needs 3. Needs 3 12AX7 tubes, so I have a few here to choose from. And I think all this really amounts to now is loading this thing up with tubes, switching it on, making sure that it works, making sure each channel works properly. The sound is of good volume and tone in that, and not much else. My intention is not to restore this to like new condition, not in any way at all. I'm going to scare you now by showing you what's underneath here, in case you forgot. That is one scary beast under there. So I'm hoping I don't have to do anything at all under here. Wow, this is yeah. Let's quickly close the lid on that. So I am definitely not trying to restore this to top performance. The name of the game is to make sure it's working. That's the objective. Okay, so next step along the way, I think, is to get the 12AX7s that I need. 1, 2, the 3 of them. So I'm going to test through my bag here and pick out 3 good 12AX7s. So there's 3 good 12AX7s, and let's look in here. So these are 6973 output tubes. These ones are brand new. They're not old stock at all. So interested to see what it looks like. Tube store. That's where when I buy tubes, that's where I go. Okay, where were these made? These were made in Russia. That's it, a little bill of sale here. And hey, look at my sticker. Okay, very good. So we're going to pop these 4 tubes in. Pop in the 12AX7s. I have to set up the speakers. I have to put power on here, and I've got to figure out a input. Some kind of input signal. Here we are, look at that. 6973 Electro Harmonics, made in Russia. Looks great, looks like any other tube. I wonder if I should, maybe I'll test these. Might be interesting, eh? Brand new tubes from Russia. How do they test? I'm not sure if I want to do that. Okay, lots of things to do here and get ready for the next stage. Okay, let's give the 4 brand new 6973 tubes here. Electro Harmonics. I'm not promoting these. This is just what I was able to buy. Oh, they're going to go right in here, for crying out loud. Put these over here. A little awkward. Switch on. Ooh, big pop in my headphones. 6.3. Let's double check the settings here before I blow up some brand new tubes. 6973. Signal level 2. Filament was 6.3. Yep. 34H. 34H. 40576. 40576. 5143, 5143, 23, and F. We're all set. Okay, this is tube number 1, brand new. So these tubes on this machine should come over just 1,000. Now that's not the actual transconductance. The transconductance, if you really wanted to know it, you would measure the meter reading by 3. There's a X3 over here telling me that. So generally they have this set up so all good tubes kind of put the meter up in the middle range here, or maybe a little higher. Okay, we'll check for shorts. Okay, and here we go. So the 1040, so it just needs to be here to reach the rejection point, and it's up here at 1650. 1650 on the first tube. 1650. Very good. Let's put the next one in. Number 2. Okay, I'll write down 1650 over here. And just for fun, we can also test one of the originals here that's still in working shape. So we'll do that last. Okay, short test. Good. GM test. Still warming up a little bit. Settling out right at 1500. So the first tube was 1650, the second one is 1500. And I don't know that that variation is significant at all. That's good. Still warming up. Oh, look what's happened here. Let's double check these settings, and it looks like, oh no, that's correct, 23. Just double checking to make sure I'm doing it right. Okay. I'd say that's 1150. That'd be 10. That'd be 1150. Yep, 1150 on that tube. Really? 1150? I doubt myself here. Yeah, I made a mistake. Well, that's more like 1650. 1650. 1650. $16.50. That's the same as the first two. Still warming up. Pretty much 1650 again. Yeah, 3 tubes that tested at exactly 1650, one at 1500. Let's try the tube number 2 again. And tube number 2 again. I'm not used to seeing such shiny tube pins. Yeah, see, it's going to come up to 1650. I don't know what I did. Well, maybe not. 1500. You know what? That's exactly what I got last time. 1500, just a wee bit above. It's crawling up a little higher. 1550. Just a little different than the other 3. I doubt that difference is significant. Now this is one of the originals. Sylvania 6973. So this amplifier came with 4 of these, and 2 of them were bad. One was dead and one had a short in it. These 2, this one and its brother, actually tested pretty good. Let's see how it compares to the brand new ones now. Still warming up. Yeah, it's going to come up to a similar reading, about 1400. That's pretty similar. So I have another one of these. Try the other one. 6973. So this is testing better than them all. At least when measuring the mutual conductance or transconductance. It actually tests higher than the rest. That's the best one. Okay, that was a little interesting. So what I have to do still here, got the 12AX7s in. I need to put in the these brand new guys, and then apply some power. I've got the speakers connected, and away we go. I'll find out how well it's working here. So I'm almost ready to start here, but a problem has developed. Somehow a cat has gotten back in behind that. What am I going to do? Holy jumper, I thought I'd look serious at times. Wow. So what I've done here is I've set up this voltmeter over here. This is going to measure the bias voltage of the output tubes. I want to find out right away if these tubes are biased correctly. So what I'm reading is not actually the bias on the tubes, but actually the bias supply voltage, which then has to make it through these resistors here. There's another pair of them up here. So that's what this is going to read. It should read minus 33 volts. That's the objective with that. Right, Shadow? Now you can see I've got a number of connections made here. This is going to supply 120 volts to the unit, and this supplies a 6.3 volts. Now I have run this amp on my supplies, so I know I can do it, except in this case I've got a full complement of tubes in here. I can only supply up to 4 amps of 6 volt power. So in order to reduce the chance of a disaster here, I'm going to measure that also. Let me get my clamp on the ammeter ready here. AC amps. So I should be able to just, maybe I can leave this sitting right here. Okay, I have to read it upside down. That's good. So I'm powering this up now. I can power it up the heaters first. That's probably what I'll do. Or do the B plus line first. I'm sorry, or do the 120 volt AC, which is going to create the B plus from the power supply in here. These capacitors over here, which you can see, these orange ones, right below my cat there, some of these have been replaced. This one, this one, this one. Some of them have not. These two and this one. Now, these are the capacitors that are blocking B plus from reaching the grid of the output tubes. And by the way, just how scary is it to work on one of these guys? Can you figure out what is going on here? So each of these are two 12AX7 preamp tubes. Well, they've got some kind of tube base extension thing happening here. It's loaded with resistors. It's a monster. This is a monster. The other thing is I keep seeing these blue electrolytic capacitors all over the place in here. Oh boy, oh boy. I just hope this works well enough as it is. Right, Shadow? She's watching very carefully. Now, Shadow, can I turn this on with you back there? Is something bad going to happen? We can certainly turn on the heaters and find out about that situation. So let's do that, because that's fairly low risk. And remember, this is upside down. So here we go. 20 amps, AC, clamped on, gotta work. I'm gonna hit the switch over here. I believe standby initiates the current. So I'm reading, well, it went up to 2.8 and it's falling. So I don't think there's a problem here. This transformer can handle 4 amps. It's less than 2.5. So I'm going to switch it off. Was that good? Shadow, did you enjoy that? Or you just giving me kind of a monkey face there? She's laid up against the speaker. Taking a break. Do you think this is strange looking on camera? It's pretty weird even in my shop here. Yes, we're laughing at you. So I think I can actually turn this on safely with that cap there. I mean, it's safe for me, right? So what we'll do is we'll put the 120 volts to it, and we'll see if that bias voltage appears on the meter. You can't quite see now. There it is. Minus 33, and it should have a negative sign. You ready, Shadow? Well, I gotta plug it in. Okay. So of course I'll be starting this with dim lights, and there won't be any current draw on the power supply because there's no heaters heating up except the rectifier. The rectifier will still heat up. Shadow, don't cause trouble back there now. So I'm pretty sure we'll still see the, well, I don't know. Maybe we'll see an incorrect voltage here. Let's see what happens. Here we go. 120 volts, Any booming? Okay, so we're seeing minus 20. Oh, don't scare me. Don't jump. Don't jump like that. That's how accidents happen, Jim. Calm down. Things can fall down. Nothing bad happens. So it's climbing up slowly. So that's definitely in the range I'm looking for. And this is with the restricted voltage 93 volts. Wow. What is drawing all the power? I've only got one light bulb in my dim bulb, so it's drawing it back pretty good. But this is very reassuring. So the next step would be, well, a couple next steps. One is I have an audio signal running just above Shadow's head there. That's right, back there, Shadow. I have a sweep running. It's running between about 100 hertz and 10,000 hertz once a second. Whoop, whoop, whoop. Should sound like that. I have it connected to the inputs. You can kind of see a yellow clip lead there. And the output of the signal generator is very low right now, which is a good idea. Volume control on this amplifier is hidden down here. Shadow's in control of it. It's turned right down right now. Minimum. Well, I guess I can turn... No. I can turn the rest of the unit on now by turning on the heaters. What we expect to hear is maybe a little bit of hum, and perhaps some of the signal coming through. Okay, stop sniffing right in there. Come on, you're causing trouble now. Maybe she can smell it warming up. That's probably what it is. Okay, here we go. Come on, cat, don't. I'm only letting you in here because I'm a sucker for cats, okay? It's the only reason. I know how boring it is in the winter in the house. What are you going to do back there now? Okay, here we go. Should keep an eye on this voltage over here, just in case it changes. Okay, we're still running with 99 volts on here, not 120 or 115. Under 2.5 amps is 2.25. This is staying nice and negative. I'm not hearing any hum. Not really hearing anything. So let's turn up the volume on the unit. Okay, come on, baby. Better make some sound. Now we'll turn up the input signal level here. We'll just kind of see what happens. Nothing. Okay, I think we've got absolutely nothing going on here, which is a bit of a problem. What could it be? So I can't do much with the amp up in this direction. So I think I'm going to lay the amp flat again. We know this is okay. We don't have to monitor it. I'm not panicky over that. Power off. Okay, heater power stays on. Heater power off. Everybody off. Okay, my cat. We don't need this in here anymore because we're reassured. Doesn't mean those tubes are properly biased because of the more resistors and stuff. Just means the bias supply is working properly. Probably the output tubes are biased fine. Pick up this heavy guy. There we go. Okay, make sure everything is safe and secure here. Should have this whole thing spun around. Yeah, let's do that. Let's spin the whole thing around. Get. So I've got the same input going to both channels. Now, why could it be that we didn't hear a thing out of this? Treble range, bass range, output, phono speaker watts. I've got it set to the 16 to all the power being directed at the main speaker because there are no other speakers. Well, I don't see anything here. Mute channel 1, these are spring-loaded mute switches. They don't stick. Volume control is still in place. The speakers are definitely plugged in, and I definitely wired them in the back here. So, like, I didn't hear anything. So let's try this again. Let's try it again here. Just move this out of here. Okay. Maybe this ground is no good. Let's put it right on there. Heating every one of them. Okay, attempt number 2. Signal level down. The output of this signal generator is very weak, so it could be I just did not turn it up high enough. That's a really good possibility here. Okay, I'm just being very cautious. Dim bulb power on. Right shadow. What evil things are you thinking about, Cat? Okay, and heater current is on. And I'm looking for the heaters to see that they're heating up here. No heaters heating up at all. No heaters heating up at all. How can that be? How can that be? Two amps flowing. 2 amps flowing. Well, it's almost a 1/4 amp for each one of these guys. So that's an amp, and then the rest of these are going to be 1/4 amp, 200 milliamps in that range. 5, 6 more. So, well, 2 amps makes some sense. Maybe I just didn't get it dark enough in here to really see the. Now there's something funny going on. Okay, there's definitely something funny going on here. Not funny, huh? Okay, let's kill the supply. 2 amps. And none of these tubes appear to be heating. Okay, so that's a bit of a disappointment. What is up? It seems to be drawing the right current, but it's not going where it's supposed to. How can this be? Okay, off on the high voltage supply. That turns this tube off, by the way. Back on with the 6.3. Is the 6.3 knocked down from a short circuit or something? No, it's 2 amps. It's not a short circuit. Let's measure the voltage. Coming in here in the darkness. They work in the darkness. Whoops. Oh, there's only 2.3 volts here. Okay, that explains something. 2 amps, 2.3 volts. I think it's a lousy cord here. It's causing the problems. Power off. Anything getting warm? These connectors. A little bit. Whole wire. This whole wire is hot. So I need a better deal there. Shadow, help me out here. I gotta find some bigger, better wire. Okay, so I put some heavier duty cords in there. We'll see. It should be more current if this has made a difference. We'll see more current here. On with the heaters. So there was 7 there for a moment. 5, 4. It's definitely going to settle out much higher. Oh, you can see it, the tubes are heating. Let's have a look. What do you say, Shadow? Let's take a look. And what's heating up? Okay, so glows everywhere. Tubes are glowing everywhere in here. Sorry, you can't really see it in the camera, but they are all there. And the cat is still there too. Okay, so we're ready again now to apply the higher voltage. So it's 3.6 amps. It's just under the limit of my supply. So I don't want to do this for too long. Oh, she just heard something interesting. She's on her way. Yeah, see, I'm only so interesting, and then something else happened, and she's off to see what my wife is up to. That's what she's done. Okay, don't waste time now. The volume's turned up a little bit. We got better access here. Let's make sure it's down. Supply volume here is minimum on the power on the. Everybody stand back. Power on. Now we could start hearing sound. Oh, how do you like that? It's coming out of this speaker. It's coming out of both, I think. Yep. Just gonna let it run for a little bit. If I put this on, what's it on? Oh, this is running on 80 volts. That's all. 80 volts. Sounds pretty good. Okay, let's take it up a little higher in voltage. I'm screwing in another bulb. So we're at 97, 98 volts. About 100 on here now. Heater current 3.6. No funny sounds. No funny smells. Test the volume control here. So there's a hum. Turn it up. Yeah, sounds great. Okay, so I'm going to remove the input signal and see if that hum disappears. So we would do it like this. This. And like that. So what you're hearing now is an open circuit of the inputs, but that other hum is gone. So this guy's working great. He's working really, really good, despite the terribly ugly underside. That's really pretty good. Let's do a thermal study on it now. I'm going to leave it running here for a little bit. Come back and we'll check out how hot it's getting. Okay, so it's been running now for quite a while. I've got my thermal viewer here, and we can look at and see the tubes. Now I got to get the angle and everything the same for all the tubes to get a realistic reading. But just looking at this, it's the rectifier tube is the hot guy. No surprise in that. And I'm going to switch cameras and try to give you a better view of this guy here, but this is a little awkward, maybe a little crummy probably. Yeah, I got a problem with the focus first. Okay, we'll give this a go and see how this works out. Just trying to let you see what I see on my viewer here as best I can. Here we go. Okay, so I'm going to aim it. So there's our 4 tubes. 2 there, and 2 over there. And the rectifier tube. Now the other tubes here, well, nothing dramatic happening. The transistors, nothing. They aren't showing up at all. Nothing on them. Anything else? Anything else showing up here? Things have to be pretty warm to make a red color show up. There's nothing on top here, so we want to flip this up now. Flip this up and over and look underneath. So can we do that with it on? Pull this out of here. Whoa! No, I can't flip it this way. I gotta shut it off and rearrange it. I gotta flip it right around. I gotta flip it over like a pancake here. Okay, let's switch it on here. So those are the sockets, the 2 output tube sockets. There's the other 2 there. I'll make this a little more sensitive in a minute. So there's a resistor there that's running very hot, 100 degrees. 100 degrees. 2 resistors up here. One is running at 100 degrees. 2 resistors, one is hot. 2 resistors, one is hot and one is not. They appear to be doing the same thing. They're involved in the big filter capacitors are right up here. So obviously that's part of the power supply. 100 degrees, that's pretty warm. Okay, found something to look at. Again, I've got this, so things have to be pretty hot to show up here. Something down in here. There's a high wattage resistor in there. That's probably what that is. A couple other items here are just not very hot at all. It's a 40 degrees in there. the way that this viewer works is, you can't see it maybe in the camera there, but there's a white plus in the middle, but there's also a red plus moving around the screen and a white plus moving around the screen. The two moving are picking off the highest and lowest temperature pixel and reporting the temperature here, down here. The white one in the middle, its temperature is reported here, 26 right now, 26. So if you just want to know what's the highest temperature in view, you just look at this red thing down here right now. The highest temperature in view is 90, and it's this resistor again. 115. That's pretty warm. I'm not saying it's a little too warm for me. Is anything building up over here? We'll make this less sensitive, or make it more sensitive now, so it'll read a lower. It'll turn red at a lower. It'll turn red about 60 degrees or so. Start turning red. So now. So anything red on here will be 60 degrees or more. So there's nothing, there's something there. That's a tube base. Probably looking right up the hole in the center of the tube base, right up at the actual base of the glass tube, up above. That's probably why there's that red circle, if you get it just on the right angle. That's the rectifier. Those resistors. Now we'll see if there's anything interesting in here, because it'll turn red. Oh, okay, so there's something. It's 60 degrees. If you get this set right, you can start seeing the wires and everything. I mean, it's foggy, right? Because it's an infrared viewer, so it's not a particularly sharp image. Well, there's nothing in here that's leaping out at me. Nothing at all. You know, that's... So that, just to be sure, that is 50 degrees, and the one up here... I thought I saw one that was higher. Maybe not. Yeah, there's nothing going on here to be too concerned about. Wonderful. That's great. Let's hear this guy work again. He's running on 100 volts right now. Oh, I don't have the input plugged in right, so I can't hear him. 100 volts, let's put him up to full voltage now. All these things will start getting a little hotter. But I mean, if they weren't, of great interest before, they won't be now either. So I'm sure these are just high wattage resistors. Wonderful. Now we're going to do the hand test, because hand reality pays off. I don't want to touch that. Can't feel a thing. Transformers. The two output transformers. Cool. Big power transformer. Still cool. I think it passes with flying colors, even though, ooh, what an ugly looking beast this thing is. Oh my gosh. I suppose I should play some music through it as the last thing. Yeah, why don't I do that? Play some real music here. Okay, so I've tried a couple of different things, including something a little extreme here. Take a look. Yes, I brought in a keyboard, hooked it up to this amp. I was going to use the demo music in the keyboard to drive the amp but you know, I don't think I can match the input impedance here properly. I believe the input impedance here is quite low, in fact, and that's all part of trying to keep this thing as quiet as possible. So unfortunately, this doesn't work well. But what I did instead is I just taken a radio and plugged it in. This isn't working very well either, because this is looking for 3 millivolts from a cartridge, not out of the earplug of a radio, but it's the best I could do. Let's see what it sounds like here. Oh, it's off. Of course, that's going to give me a copyright hit doing that, unfortunately. So I'm not able to supply it with a really nice signal to listen to even myself. Often after I finish a radio and that, I spend time listening to it myself. I can't put it on video because it just gets a copyright hit. And that's the situation. I think this amp is good to go. I don't think there's any advantage to me doing anything more with it. It's great. Fantastic. Okay. On to the next project, in fact. Thanks for watching the series on this. And if you're about to do a big job on one of these amps, good luck. See you on the next video.